So as we move into chapter 19, this is going to involve right triangle trigonometry. So we have this word trigonometry that we're dealing with. This may be new to you, trigonometry. So trigonometry is kind of the study of angles and sides. It kind of puts the two together. And one of the shapes we start with is what's called a triangle, or more specifically, we work with a right triangle. So some vocabulary dealing with a right triangle. So right triangle, we have one right angle and we have two acute angles. So in a right triangle, the sides that make the right angle are called legs. So A and B are sometimes denoted as your legs. And the longer side of the right triangle is called the hypotenuse. And a lot of times it's denoted as the letter C. So again, the legs refer to the sides that make the right angle. And the hypotenuse is that long side that's opposite of that right angle. And what happens is, you may remember this, there's this formula called Pythagorean theorem that says c squared is equal to a squared plus b squared. So where c is the hypotenuse of a right triangle and a and b are the legs. So we have this special formula that allows us to find the lengths of missing sides of a right triangle. So if I want to use Pythagorean theorem, I can find b when a is equal to 8 millimeters and c is equal to 17 centimeters. So again, using Pythagorean theorem, it says c squared is equal to a squared plus b squared. So substituting in, we say c is 17, and we know a is 8. So I have to replace the c with 17, so that's 17 squared equals then this a squared, which actually is 8. So sorry about that. We'll back up there. We'll replace that with an 8. So 8 squared plus then this b squared. So to solve for b, we have to subtract the 8 squared from each side. So that's going to be 17 squared minus 8 squared is equal to b squared. And then we have to take the square root of each side to get the answer. And remember, when you take the square root, this is supposed to be a plus or minus answer. But remember, we're talking about the length of a triangle. So the plus or minus does not come into play here. This is simply going to be a positive answer. So using my calculator, I don't actually have to work this math out. I can just put it in as is. So the square root of 17 squared minus 8 squared is going to equal b. So if I just leave that math like it is, I can then just use my calculator. Let me again adjust this again. Jumps on me. So if I hit the second button, hit the square root button, I can put the 17 squared minus the 8 squared into the calculator and hit enter, and that'll just give me 15. So the missing side here, b, would be 15. And since we're talking millimeters, that'd be 15 millimeters. That would be a linear measurement. If I look at example 2, find the center to center distance between the pulleys A and C. So they want us to find the distance from center to center between the pulleys. So we have this is what they're looking for. Notice that this distance is given to us, and this distance is given to us. So notice how this creates a right triangle. So I can apply the Pythagorean theorem to this problem, where c squared is equal to a squared plus b squared. Now the catch is, what's the a, b, and the c? So remember, the sides that make the right angle are the a and the b. So notice how the 10 and the 15 are actually the a and the b, and the longer diagonal side is actually the hypotenuse. That's actually c. So c squared is going to equal then this 10 squared plus this 15 squared. And then to get c by itself, we got to take the square root of both sides. And again, we don't need to worry about a negative answer because we're talking about actual lengths here. So a length cannot be negative. So the square root of 10 squared plus 15 squared would be our result. So if I clear off my calculator, hit second square root, and put 10 squared plus 15 squared and hit enter. Notice how we would have to round this to a decimal place. So we could say if I rounded to 2 decimal places, that would be 18.03, and this would be in inches. So that would be our hypotenuse, or the length from pulley A to C, the missing distance. Some other things to pick up on in right triangle trigonometry are just talking about some other vocabulary. There's also what we call an isosceles right triangle. An isosceles right triangle it's a right triangle, but two of the sides are equal. Notice how these legs would actually be equal, which means these base angles are also equal. Now, by definition, the sum of the triangles will always add up to 180 degrees. So that's another little definition we need to pick up on, is the sum of the angles of a triangle will always add up to 180 degrees. So if I have angle 1 plus angle 2 plus angle 3 of a triangle, all three of those angles have to add up to 180. So if we have a right triangle that's got a 90-degree angle in it, and the other two angles have to be equal, they would both have to be 45 for this to work, because 45 plus 90 would equal 180. So if we have an isosceles right triangle, what we know is we have what's called a 45, 45, 90-degree triangle. And that's very common, especially in construction. We have that's one of the special tools we use in a construction, is a 45, 45, 90-degree triangle. Now, one of the things we can do, though, is if we use Pythagorean theorem, we can discover, though, that if we have the legs, if we have x and x, we could say that, c squared is going to equal x squared plus x squared. So c squared would equal 2x squared. In other words, c, if we take the square root of each side, c would equal the square root of 2x squared. In other words, c would equal, notice how there's two x's, they have to come out as an x, and we have the square root of 2. So in a 45, 45, 90-degree triangle, the legs will have to be equal, and the hypotenuse is going to be the leg times radical 2 times the square root of 2. So we have some special strategies here. So if we have a 45, 45, 90-degree triangle, the hypotenuse is going to be the leg times radical 2, or x radical 2, and each leg will just be x. So that's some things we will need to know. So if I give you this triangle here, if I want to find the hypotenuse to the nearest thousandths of an isosceles right triangle, there's two ways of doing it. One way would say c squared is equal to 2 squared plus 2 squared using Pythagorean theorem. So c would equal the square root of 2 squared plus 2 squared. So if I put that into the calculator, second square root, and put 2 squared plus 2 squared in the calculator and hit enter, it'll give me 2.828. If I round to the thousandths place, since that 4 is going to keep the 8 the same. Now, the other way to do it is, if I know a leg, I could find the hypotenuse by simply multiplying 2 times the square root of 2. So the other way to do it is just simply type in to your calculator 2 times the square root of 2 and hit enter. That should give you the same answer. So if I can remember that this is a 45, 45, 90-degree triangle, there's actually a shortcut that says all I got to do is multiply to get the hypotenuse is simply x times the square root of 2, or leg times the square root of 2. Since our leg was this 2, that gives us this 2 square root of 2, which in turn gives us the same answer. Another type of triangle is what's called a equilateral triangle. In an equilateral triangle, that means all three sides have to be the same. If all three sides are the same, that means all three angles have to be the same. So if you divide 180 divided by 3, that's going to give me 60. So in an equilateral triangle, all three angles will have to equal 60. Now, if you draw in the altitude, notice this top angle is actually going to be broken into 230s. So if we look at this triangle here, though, notice that this triangle here is actually a right triangle. So this would be what's called a 30, 60, 90 degree right triangle, which is another important triangle that we see. So if we look at that, notice how we can kind of apply some things here. So in a right triangle, notice how if we have to begin with, if we draw the equilateral triangle back in there, notice that if this is 2x, that means this is 2x, and this distance across here is 2x. But notice how this would only be half of that. That would just be x. So we pick up on that in a 30, 60, 90 degree triangle that the short leg is going to be x. The hypotenuse is going to be 2x. It's going to be twice the short leg. Now, the other thing we can pick up on is, if we use the formula, a squared plus b squared is equal to c squared, we don't know where this is coming from. But what I can do is use this and this because we do know those. This is going to be like a squared plus x squared is equal to 2x squared. So this is going to be a squared plus x squared is equal to 4x squared. So this is going to be a squared is equal to 3x squared. If I take the square root of both sides, a is going to equal, x is going to come out, and the square root of 3 is going to come in. So there's actually a formula that we can use for a 30, 60 degree triangle. So in a 30, 60, 90 degree triangle, the hypotenuse is going to be twice the short leg. And the height is going to be the short leg times the square root of 3. So all this revolves around knowing what the short leg is. So notice how if I give you the short leg of 7 inches, then I actually could find the hypotenuse by just doubling it. So from A to B, that distance is going to be 14. Now, notice how this is opposite the 60 degree angle, so this is kind of what we call the longer leg. So the longer leg, which is going to be B to C, this is going to be the short leg times the square root of 3. So it's going to be 7 times the square root of 3. Those will be the exact answers in that problem. So again, we have these special relationships that we can kind of take note of. 30, 60, 90 has these special relationships here, and a 45, 45, 90 has these special relationships that we can take advantage of.